And our next speaker is Alister Burt. So Alister did his PhD actually relatively recently with Irina Guch, where he worked on higher resolution, pulling the resolution of bacterial chemoreceptor arrays. Then he moved on, and I still don't quite understand how he did this. He moved to David Barfoot's lab. It has nothing to do with tomography, but single-handedly pushed tomography forwards, and then recently moved to the dark side and went to Genentech, but has continued to push tomography workflows. So he's going to be telling us all about latest work in Warp-2. Thank you, Alister.
Thank you so much, Morgan. Hi, everyone. Can you hear me okay? Everything's good? Amazing. Thank you. I appreciate the... yeah, my name's Alister. I work in Dmitry Teganov's group at Genentech. And quickly, what does cryo-EM look like at Genentech? So I thought industry meant industrial scale for everything. That's not necessarily the case. It's quite a lean operation. It was started by Claudius Ferri. Alexei now runs it. Matt, Kaylee, and Przemek run the scopes. Przemek is our only tomography user, and he's fantastic and doing amazing things, but he is but one person. Would love to be doing more. And then Dmitry and I write software, and that's kind of what I'll be talking to you about generally today. I'll start out, I love cryo-ET and kind of all the workflows and things around it. I've had too much experience with, and yeah, I like to think about it in terms of these three blocks. So we've got pre-processing, everything from the raw data from the scope all the way up to tomograms, particle picking, tomograms to some set of initial particle poses and a reference. And then refinement is the process of going from this initial guess to your final crispy map. Yeah, what will I talk about specifically today? I'll start out with a bit of context, what limits our resolution in subtomogram averaging. I'll talk about some open source goodies that are not even strictly things that I do in my day job, but they're things that I care about and like to put time into. And then I'll give you some updates from Warp-2 and friends. So if you are less technical, you might not be super interested in the little piece in the middle. Please stick with me. I promise we have some things for you later. Okay, what limits our resolution in subtomogram averaging? So three main things from my perspective. Historically, less so now, improper treatment of the CTF, errors in your projection geometry, so your tilt series alignment's not very good, and so your particles don't look great, and just not being able to get a good set of particles to take into rely on or wherever you're going to do your averaging. These are the big three. So CTF, in case people aren't familiar with CTF in tomography, the specific considerations, it's this aberration we have from the microscope. As you increase your distance from the focal plane, your defocus, your CTF will oscillate more quickly as you go to higher spatial frequency. And then when you have a sample with appreciable thickness, the difference in defocus between the top and the bottom of your sample is enough that you need to start accounting for this. First done by Grant Jensen very long time ago. And then for tomography, I think the thing that everyone got really excited about was when Beata did it in John Briggs's lab, properly accounting for the two defocus gradients through the thickness and also as you tilt your sample and pushing the resolution of subtomogram averaging down to 3.4, very exciting. Errors in the tilt series alignment. And this is a little bit more tricky, and it's only more recently that it's kind of been solved for by now multiple packages. So here I've done some simulations of a nice reconstruction of a ribosome, and I slowly introduce more and more shift errors. And you can see that at the beginning we had a kind of nice crispy ribosome, even though it's a tilt series and it has a missing wedge, or it's a reconstruction from a tilt series and it has a missing wedge. The quality is actually really good. You can see quite a lot of detail. And then as you add the shifts, it really drops off very quickly. And so you can imagine if you try and average these particles with those errors kind of baked into your alignments, it's not going to go too well. Here is Jan from my PhD. He's a very capable postdoc, and we used to spend lots and lots and lots of time making sure that these alignments were about as good as we possibly could get. Not many people spend as much time on this anymore. It maybe makes more difference than people think. We have nice push button solutions now. This is great, but I still see a lot of people not getting amazing results, and maybe they're not spending enough time here. Inability to get a good set of particles. So Warp only provides template matching and then says you're on your own. I needed something else when I was doing my PhD, and so I put together this workflow that allowed you to go between Warp and Dynamo. And yeah, Dynamo had a bunch of amazing tools for picking particles on ultrastructural features, so filaments and spheres and surfaces, whatever the thing was right for your system was. And yeah, this gets you to your particle positions. I think this is really important. And if you have prior information, you should definitely be using it. Maybe you need to do something a bit custom to get to that good set of particles. So when I was at the LMB, I was really lucky to get to work with amazing scientists on this really cool project, looking at the gamma tubulin ring complex on the end of the spindle here in these yeast spindle pore bodies. And they were stuck using the workflow that I'd kind of established during my PhD at about 11 angstroms, despite refining with microtubules as well, that were going all the way to 6. I came in and my only contribution was on the averaging side, but yeah, we were able to identify some misaligned subsets of the data by doing 3D classification and limiting alignments to quite low resolution. And so we could see pretty clearly that, a good chunk of the data was not really aligned. We put together a little workflow in, we all like to use Chimera X or Chimera to move our maps around. And so built a little tool that just lets you in Chimera align everything to one class and then apply those alignments to subsets of your particles. And this really cleaned up the density at the seam of the microtubule on this, microtubule capping complex. And I can't remember why, but they cared about this little bit of density here. I think it was some little thing. Yeah, another thing that we did and thing that really allowed us to push the resolution, there was this really weak density that we saw kind of bridging the microtubule to the gamma tubulin small complex at the top there. And there are 7 copies of this small complex. And so we said, if we can, instead of treating one particle as the whole object, leverage this multiplicity, we have 7 copies of this, recenter the particles, make sure they're all aligned properly. This massively cleaned up this density. They were able to say that it's a coiled coil protein and unfortunately not fully pin it down. And so that was the kind of missing piece in this work. But yeah, it was a super fun project, lots of cool little things. I still think it's important to properly think about the geometry of your problem quite carefully. And if you can leverage it, do. I'm going to talk a little bit now about the open source things that I like to do. These all generally come under an umbrella that's now called Team Tomer. These are small, useful Python packages for doing cryo-EM and cryo-ET stuff. So tomography pipelines, probably you all want the perfect pipeline. I want the perfect pipeline. It would be great. But the reality is, lots of software developers doing different things in different places. They don't necessarily know about everything that's going on in all the other packages. And so making these things talk to each other, huge pain point. The way that I solved this for myself during my PhD was I started writing little Python packages that let me, read and write star files and dynamo files and do Euler angle manipulations. I also worked on this really cool thing called Napari that is by far the most impactful thing I've worked on. If you look at the download numbers here, it's much more well used. Yeah, unfortunately in cryo-EM, I think people have had a bit of a bad experience because they tried to install it with Reliant on a HPC and it was not supposed to be used remotely ever. Yeah, this lets you do cool stuff like custom visualization, or maybe you've got some little analysis that you need to do where you exclude particles based on distances to something. We can't write command line tools for all of these little workflows. It's complex biology. Your problem's probably a bit specific and I probably haven't seen it before. But yeah, enabling people to solve their problems is, I think, very important. Then when I moved to the LMB, I was doing things in Reliant and I was doing things in David's lab's ongoing projects, but I was also surrounded by so much really cool expertise in the image processing side of things. And so I started playing with actually the more, the algorithms and this side of things. I'd enjoyed thinking about this a lot up to that point, but I hadn't really engaged with trying to develop any of it. And so I played with, re-implementing Dimitri's motion correction and local CTF estimation algorithms. And yeah, a little package that came out of that was this torch cubic spline grids thing. I won't go into too much detail because I don't have masses of time. But yeah, I started putting these packages together under an umbrella called Team Tomer on GitHub. And so the idea here is pretty simple. It's that Team Tomer is a place where there's a bunch of people who will contribute and develop infrastructure together. So this is like kind of low-level packages that let you do useful things. And then if you've got scientists who are willing to do a little bit of scripting, more and more people come in with a little bit of Python experience, or is getting taught at university. Ewan, you're a great example of this. I saw you smiling. They can then solve their own problems. You're going to have problems. We're not going to have solved them all in the software packages. You should be we should make it as easy as possible for you to go and solve them yourself. And then anyone who wants to develop cryo-EM software, at the minute, you kind of have to reinvent the entire world. The world is really big. There's lots of stuff that's already been done. I'd like it if it was easier to take out of the toolbox, the things that are already solved, and then just build your little piece that's new and exciting. And then maybe if these developers are good-willed, they contribute something back to this ecosystem, and then we have another brick, and we can continue to build together. The thing that I'm most proud of is that this is not something that I have been doing entirely by myself, but we have 45 people now who've contributed code. Some of those it's one line, tiny fix for a tiny little thing, but other people have really invested in this and have started spending meaningful time building packages that do the things that they're interested in, and building them in this nice modular way is hopefully going to get us towards a state that's a little bit better for new people who come into the field. Yeah, Johannes, who talked yesterday, he's been very active and contributing a bunch of useful stuff here, and this is a nice message that I got from him on a PR at some point. What have we actually got? What functionality is available to you? So started out with just kind of file input and output, and so some of these domain-specific file formats, we all don't want to be writing parsers for them. You can do this, and these have been downloaded a bunch of times. People like to pick up and use the thing. They don't actually want to re-implement this stuff. It's a pain. And then, yeah, particularly, Relion has been hugely popular for a long time, and especially with tomography, people need to modify these star files a lot. And so that particular project has been used in over 100 people's GitHub repositories, and I'm sure countless other little scripts somewhere. So if that's been useful for you, thank you. And if it's not working for you for whatever reason, because it hasn't seen your data yet and it isn't working, do send open issues and things. The more recent additions are this whole kind of set of the basic cryo-EM specific image analysis routines that we use. And so these are all implemented in PyTorch. That gets you GPU basically for free, automatic differentiation in case you want to do ML or optimize parameters of a model, all these kind of things. Don't worry if that doesn't mean anything to you. If you ever want to play with what happens if I simulate a tilt series and stuff, there's a bunch of useful utilities in here. And if you have questions about how to use any of it, pop up on, I'll link some channels and things where you can talk to us. Yeah, people are using these packages to build some cool stuff. So Martin Chaillet, who you might have seen at this conference over there, he popped up, and then I didn't really hear from him for a while, but he seemed interested, and then he finished his PhD. So I assumed that there was some kind of busyness that was going on. And then he re-implemented RTOMO for fun because he really wanted to understand how it worked, using some of these core pieces and having to build just a little bit around it. Here's a tomogram aligned and reconstructed entirely in Python by him. I'm not saying you should be going out and using this re-implementation, but it just demonstrates that it's a thing that you can do. And if you want to understand, or if you want to build something new, these tools really do work. He's now developing ML methods for tilt series alignments, and is also leveraging a lot of this infrastructure. We've also got people like Ruben, who we overlapped a little bit in Oxford. We never worked together, but he was interested in the Fourier slicing implementation. So projections and back projections by taking slices in Fourier space. He has recently put out a preprint on some routines that they developed, where I think his postdoc was in collaboration with Aztecs, and they're using it for drug discovery to speed up things that are routine in their pipeline, just to, infer through, don't have to do all the searches over alignments. The one that I'm particularly excited about at the minute is Josh Dickerson, who used to work close to me on the floor at the LMB, and Matthew, who's a grad student, they're both in Bronwyn Lucas's lab in Berkeley. They've re-implemented systems template matching, the 2D high resolution stuff. The reason they wanted to do this is because if you want to run slightly custom routines, maybe you want to find your ribosome and then just search locally around the thing over here, this kind of thing, they would be able to tell you better exactly what they want to do with it. But I think it's a cool demonstration that you can build quite complex pieces of software, and they're really benefiting now, I think, from the extra flexibility of having it all in Python, where things are a bit more kind of easy to experiment with. You can visualize stuff, and yeah, it's good. Okay. If you want to get involved, issues and code, GitHub, we have a real-time chat thingy that you can pop up on and introduce yourself. It's a Zulip chat. And we run a Zoom meeting like once every few months, all very low overhead. It's not very official. If you are interested and like want to, please come along. Another thing that I'll talk about very briefly is I've done some fun work with Aisha, who's also here, Aisha, on this thing called Impari Thomas Slice, which is if you use the particle picking tools in Relion, just kind of factoring those out into a standalone application that is not installed, hopefully, on your HPC. And yeah, I hear some laughs. I appreciate this. And yeah, can be used with, not just rely on whatever subtotal averaging package you might be working with. And so she's done a great job of kind of wrapping this up and turning it into a thing that you can actually use. And she's learned an amazing amount during the process. It's been really fun to work with you, Aisha. So you can annotate different things on this nice, render a slice through the volume. You can manipulate the slice. You can move stuff around. It's all fun. Particles, paths, spheres, dipoles. And then you can kind of generate your particle poses from those annotations, and then you can output them for a bunch of different subtotal averaging packages. If we don't support the thing that you want output for, provide us some examples, and we're happy to work with you to do that. Yeah, there's also a nice documentation site that will hopefully get a bit better over time, but it's already a thing. Okay, now to the main part of the talk, which is updates from Warp and friends. So Warp and M is this workflow. I'm not going to describe it in too much detail because Dimitri did an amazing job of that a few years ago here, where he first started talking about M. I did not develop this, it's Dimitri's work. But Warp kind of handles a bunch of this pre-processing. He likes Relion as a refinement engine, and so outputs to Relion to do your kind of 3D pose searches on your potentially not yet super crispy particles. And then M is this thing at the back that optimizes everything and hopefully gives you a high resolution map and a better description of your alignments. You can actually use this to then reconstruct nice automograms, and it's very fun. The way it does this, it's reference-based optimization. So once you know where your particles are and which orientation they're in your 3D space, you can use that knowledge of the high resolution references to optimize your description of the particle poses, but also global sample deformations and electron optical parameters. And yeah, this on desktop in Windows had this really nice GUI experience that I know I really appreciated when I started using it after having bashed against the command line for a while. You can kind of see all the things that you need to and not a lot more, and that's great. The problem was that they were only available on Windows. This made sense because the microscope PCs run Windows, and Warp was originally supposed to run on the microscope PC, and then it kind of expanded beyond this. And so what we've done a bit more recently is free it from that Windows cage. You can now run it as a set of command line tools on Linux. This is definitely something I know I wished for when you're battling against files that overwrite each other and needing to get files from the Windows to the Linux. For people who hopefully your eyes don't completely glaze over when you see the word Conda. I know it can be a bit painful sometimes, but this is a nice way of installing it. And yeah, if you have any issues with that, please do let us know. It's been taken up quite nicely now in a bunch of labs around the world. I've really enjoyed interacting with hopefully some of you who are in the audience on helping you get it running or helping you troubleshoot little things. Thank you. I appreciate that when it's a new piece of software, there are teething issues and not everything is as simple as we would maybe like. Yeah, M is a very capable refinement engine. And so I don't know if this is still true. I haven't really actively looked, but I think we still have a couple of resolution records for things. So there was this cool in situ lamellae ribosome work from Martin Beck's lab where they got down to 2.5 angstroms. It's impressive. Martin Ober in Abe Katech's team at Thermo Fisher did 1.5 angstrom apoferritin tilt series. I'm sure that was the most fun processing that's ever been done. And then Dimitri actually reprocessed this data from Holger Stark's lab with the CS-corrected Cryos and got it all the way down to 0.99 apparently. I think there might be some controversy over that. Don't really know the details. I care about documentation being good, and so I have written a kind of guide to getting started. This is also what we run through in workshops and things, and so you can, in a couple of hours, ideally, if you don't have too many computing problems locally, run through 5 tilt series subset of one of these empire datasets with apoferritin, and having that experience of really seeing all of the steps and seeing how it all kind of weaves together, I think is very useful for people. Not everyone likes to read, so we do also run workshops. I really enjoy these things. It's a fun part of my job now, to kind of get to still interact with the academic system in this way and spread what I think is a useful tool, and hopefully people are interested in learning it. Now, we also understand not everyone loves the command line. I know that I was like, oh yeah, I asked for this thing, but actually I kind of like the GUI. And so we have been working on a web-based GUI solution. It's called Relay. Dimitri has been really pushing this hard recently. And yeah, it's a web app. You know, you can kind of log in, and once you're logged in, you end up in this kind of project screen. You might feel familiar, and you can tell that Dimitri was quite excited about the emojis that he got working. He had to build this emoji thing himself because we use a C# Blazor library thing. Yeah, so yeah, we can go in and we can process data. So we import a data set, and then once the data set's imported, you can start to run jobs. So here we run a motion and CTF job. They're combined. Whoa. And yeah, when it's running, you can kind of see some useful things. How long has it been running for? How many items have been processed? This will feel quite familiar for anyone who used the Warp GUI. You've got this kind of carousel of images, and then the different statistics that you might care about. There, Dimitri cares about the way these GUIs feel, and I think he's done a really good job here of making it feel great. And then you can look for any particular image at the quality of the CTF fits, and yeah, the image itself, all these kind of things. Yeah, we also have visualization things involved for tilt series. So if you just want to quickly see how your tilt series looks, so you can just hover over at the top there. If you want to look in a bit more detail, you can drop into any images, select, deselect things. All of this is very fun. Even preview your tilt series alignments if you do a tilt series alignment job. So kind of just a live rendering of that aligned tilt series there. And you can see here kind of if things track straight across along X, that means that your tilt series is aligned well normally. It's a useful preview. We've got kind of tomogram visualizations, nothing super fancy yet, but it's really functional. It's nice to be able to visualize things there and not have to download files for everything. Here's just a preview, dark mode, if you want it. I don't love dark mode, but dark mode is a thing. And then this is an example of a refinement job where we still interface with Relion as our refinement engine. And so here's a 3D classification job on the tutorial data for Relion, and you can see kind of the map update, and you can go through all the iterations, and you can see angular distribution plots and everything just in that interface. Yeah, that's everything I kind of had to say. I hope I didn't rush through too much. Small reminder, just because we have nicer and nicer tools does not mean that tomography is easy. Yeah, it's complicated biology. The floor on the complexity for tomography problems is definitely much higher than what you get in single particle. And yeah, we need to recognize that you might still have to do some custom stuff, or it might not be easy to get these results for all projects. Yeah, with that, I've mentioned people's faces and names and things, but these are the people that I've worked with more closely in various different places over the years. I'm really happy that I still get to be part of the CCP-EM community, and thank you for the opportunity to talk today to the organizers.
Thank you, Alister. Any questions from the audience?
Hi, Alister. Thanks. Looks great, and I think Warp for Linux is a good idea. And the GUIs, they look great. I was wondering, given that CCP-EM puts a lot of work in web-based GUIs and interactions with Relion and so on, that could also be a platform in which Warp and M could contribute to. So what's the overall vision there? Will this remain completely separate with their own GUIs and so on, or are there kind of plans by Dimitri and yourself to integrate more with the CCP?
So yeah, my take on this is that the pieces that we would be trying to integrate if we tried to do this would make it quite difficult to have it be a really good experience. So, you know, Reliant has its own parallelization infrastructure and all of this, and then Warp deals with this in its own slightly different way. I think I care about this Team Thomas stuff I talked about, because I think if we want to really get nice experience integrated over the long term, we need to be relying on more common infrastructure than we currently do. And so I don't see a clear path to fantastic integration there at the minute. I think that's the current state of play. I would, you know, love to be working more directly with more people. I think it's silly that we have lots of these independent efforts going on. I'm also not fully in control of decision making, you know, how we do this specifically. But yeah, I appreciate the fallout of it, and it's definitely a thing that we want to have a better handle on in the future.
More questions?
There's a couple down here.
Thanks, that was a really nice talk. With the web interface, how are you kind of doing the processing? Are you doing it locally on that computer so it runs on there and then you process it into it, or are you doing like a Slurm thing, or are you doing something more like PriceSpark where it has its own queuing system?
I have a couple of extra slides. I didn't put them on this presentation. Maybe I can show you later, but we have a similar to what's in CryoSpark. It interfaces with the job queuing system through scripts that you write, and there are templated variables and all of this. And so you can run it kind of anywhere that can talk to your cluster, and then you can submit work to anywhere on your cluster. We don't do anything fancy with the cloud or anything like that. If you wanted to link it up, it might be possible, but we don't take on that complexity.
So, one other little question as well. Are you planning to make it sort of modular? I guess this kind of ties in with Doppio, and it's the other side of it. Like, would you try and make it modular so people could add, for example, particle picking systems into it themselves, and then that can be a thing that appears as another job within the interface?
I don't know exactly kind of Dimitri's whole vision on this kind of stuff. I imagine we will need some support. We definitely support importing results from various different places and things. And so if you need to get particle positions in or whatever, we know we don't provide all the solutions for everything. But I don't think I can speak on specific plans around whether we want to open it up to other people or this kind of stuff. My guess would be probably not, but I'm also not speaking authoritatively.
More questions? Okay, bearing in mind that lunch is next, I think we better move on. So let's thank Alister once again, please.